Hello, I'm Piers Meyers. I'm part of the software experts community at Orange. I'm a developer and I've been working for a while on the logs topic. I would like to share some valuable stuff of my own experience through this open source project that is called Woofer. This is the third video about Woofer, and in this video I will show you incident analysis in practice. Basically, I will show you how, thanks to coding magic in Woofer, you will be able to track down an error from Woofer, from the user interface, to Kibana. And we will be able to retrieve the complete stack trace of the error, also to spot the root cause of the error, and to filter logs from the requests, and also filter all the access logs that occurred during the request that the error occurred on. The prerequisites for this video is that you already have an ELK stack installed. So I recall you that ELK stands for Elasticsearch, Logstash, and Kibana. You have a Woofer installed and configured to push logs to Logstash and to Elasticsearch. And you also have set up some Kibana Discover searches. And for this, you have to see the previous tutorial. Let's go. So again, I will use Woofer and I will log in as Brad Pitt. Fine. So you already know that through Woofer, I'm able to post very short messages that are called woofs. But something that you might not know is that if you hover your mouse on this eye sign, you can see that you can trigger some kind of Easter eggs. Let's say if the body of your message contains something like ERR colon front, back, or notifier, that will trigger an error during the treatment of the woof in the targeted components. Same thing for slow. You can cause a slow treatment somewhere in the treatment of the woof on the targeted service. So, well, let's play with that, and let's post a woof that will, on purpose, trigger cause an error on the backend system, for instance. Okay, hi ERR back. This is nonsense, but anyway, this is just for playing with errors. Okay, I'm Brad Pitt and I am going to woof this. Oh, too bad. So Woofer is telling me that an internal error occurred. You can see that this is one of the practices that the message is not technical. It's only something that we feel very sorry. We are working hard on it. But I still have some more details, and here, well, the message is not technical, so in an internal error, it's not the place to dump a full stack trace, because most users will not understand that, and it's not pretty serious, right? But the interesting part is this. This is a unique ID that has been generated on the fly to track down the error, and that is the key that we will use to well, to find the complete stack trace and to in the end spot the root cause. Okay, so let's pretend Brad Pitt is really upset, and we call the support. I had this error posting my woof. So on support side, we will ask what was the ID in the internal error. He will translate it to the support, and then I will play the role of the developer that has to perform incident analysis. And let's say it's pretty urgent because it comes from Brad Pitt, right? So I'm in Kibana. I know that that was a Java error, so let's open the Java discovery search that we previously set up. And as simple as that, I would just paste the ID of the error that Brad Pitt had. Okay, and now in just one single interaction, I'm able to retrieve the log that contains the error message, but, which is very interesting, the complete stack trace. Let's have a look at that. First thing, you can see that this unique ID is made of two parts separated by a dash. The first thing is not unique at all. It's the first thing is a signature hash that is generated by one of my contributions that to logstash logback encoder, which is an add-on that works with logback and that is mainly able to push Java and HTTP logs directly to Logstash without going through a flat file and using filebit to push the logs. So that is a very nice add-on to Logback that I like very much, and that's why I contributed to it with this feature. So what does it do? Basically, when any error occurs, you will have a stack trace, and my feature is able to compute on the fly a unique signature. That means that anytime you will have the same error occurring in the application, you will always have the same hash. So let's say this hash is stable, okay? But the second part is unique. So in whole, this complete ID is only for the occurrence of the error for Brad Pitt. But if any other user had the same error, then the first part will be the same and the second one will be unique. Okay, that's it. I have the stack trace, and let's try to understand what went wrong. So we can see that this error occurred in the web front component, right? And the root cause on this stack trace is that, well, the web front received an internal error from the Woof's client post. I know because I have developed the application. I know that the Woof's client is a client that makes requests to the backend. So that means that probably the root cause is not in the web application, on the web front, but more on the backend. And by the way, you can also see that in his internal error response, the backend also sent me a unique ID. So I will copy it, and well, I will use it to drill down this investigation. And now, okay, I only have, yeah, I have two hits. The first one is the first error I had. Why is it matching my request? Very easy. It's just because, yeah, the ID is part of the stack trace we just saw. Okay, and the next one here, indeed, we can see that it has been emitted by the Woofer backend, and this is the root cause. We will see that. So what is it telling? It's telling that the woof content caused an unexpected error. And okay, what was the error? There is this class, unexpected error simulator, maybe throw on line 19. So let's have a look at that. Let's come back to my IDE, which is IntelliJ. Yeah. Okay. Unexpected error simulator. I have 3, and this one was in the backend system. Line 19. Okay, I see now, and I can see that indeed, when a woof body contains ERR colon back, then yes, it throws a runtime error. So it doesn't really look like an exception, a bug, but more a feature. But well, you know, that's why Woofer has been designed, is to play with logs and to play with tools around logs. Okay, so let's come back to Kibana, and I will show you a bit additional things. If you had a look at Woofer's website, you may have noticed that I'm also using Spring Boot slots to make distributed tracing. What's that? So basically, the idea with Spring Boot slot that is that it's able to track and to correlate logs from all the microservices in my architecture during one single treatment. What does it mean? When one request is processed by my system, my complete system with several microservices, we will most of the time have several requests and responses back and forth, maybe some asynchronous processing within the same microservice and so on. So it makes things very easy to very hard without sloth to track the request processing and the path that is the path in the way the request is processed. But thanks to sloth, you always know that all the logs emitted during the treatment of one single request incoming in the system will share this information, the XB3 trace ID. So I will just filter all the logs with the same XB3 trace ID. Nice, and I'll just remove the error ID from before. And yeah, here I see 4 logs that give me exactly all the logs that were emitted by Woofer during the treatment of the post from Brad Pitt that made the error. Okay, we can see that the first log was emitted by the web front, and it's an informational log that tells me a new woof is posted. By the way, we can see also in the user ID column that indeed it was posted by Brad Pitt. Then we see another information log from the backend service that tells me that, well, Brad Pitt is posting a woof, and I can even see the content, which is not good at all in terms of security. But well, Woofer is just here for playing, so this is something you should not do in your applications, in a real life application. But yeah, here it's nice to track things very precisely. Okay. Then we see that well, an error occurred in Woofer backend, and that's the error we had before. It's the error that says that the woof content caused an expected error. Okay, and then another error occurs in Webfront because it just received 500 error response from the backend, and that's the first error we had. Nice. So you can see that thanks to Flood, we were able to correlate all the logs during this single treatment. But that's not all. You know also that Woofer is logging access logs, and in Woofer's configuration, I did all necessary in order to propagate this Spring Sleuth information to access log 2. Okay, so if we will keep this XB3 trace ID, and we will try to find all the access log that occur during these treatments. So basically we will change the view, we will switch from Java logs to HTTP logs, but we want to keep this. So to keep this, I will have to pin the filter and then open HTTP logs. Okay, and you can see that the XB3 trace ID filter is still on, and I have 2 matches, and that's exactly the 2 requests that were performed during the treatment of this post. And you by the way, you can also see that the first, well, we had the backend system that were called on posts on API woofs, and that the answer was 500. And then we also have, well, the woof on the web front that, well, that was also erroneous, well, due to the error that occurred on backend. Well, that's it. I think I demonstrated how to make use of logging tools and practices in order to make an incident analysis. And you can see that with the right tools, it's very quick and cool. Thank you for attending.